everyone, welcome to the MathSpellBook live stream. I'm your host Peter, and basically we're going to do some proof writing exercises today, in addition to probably just get ourselves like practicing some of the stuff that Sascha has taught us thus far. So basically it will be just me, me this stream today. If you're watching this on YouTube, consider hitting the bell, hit the notification bell, comment, like, subscribe if you like. In addition, if you like math or physics, or just basically need a productive stream to keep yourselves like going, just basically follow the channel if you're watching this on Twitch. And yeah, so let's just basically be productive now. So I'm basically just trying to get some actual proofwriting practice, because proofwriting is quite difficult. So let me just I'm just gonna turn on the math chat here. So let's turn on the study timer. Okay, so we'll start off with like the first thing that Sascha assigned to us. Proofwriting always. Hey, Adam Fighter. I always forget how cool your name is, Adam Fighter, because I also like physics. So proofwriting I always wanted to learn. Yeah, me too. Proofwriting is very, very difficult because it's rigorous. So I think I'm going to do, let me just minimize this, so I think it will be much easier. So we'll minimize that, and then take a picture, and then we'll copy this, and then take this, and then we'll paste it in here. Yes, allow, please. Okay, let me just drag this here, so that way we don't have to keep going back and forth to the pages. So let's stretch this a little bit, like so. Okay. So exercise 1, let F, hopefully you guys can see that. Hopefully it's not too small. I will try my best to write everything so that the chat doesn't block everything that I write. But anyway, exercise 1. Let f be a function that maps A to B. Be a function if x1 and x2 is a subset of A, and y1 and y2 is a subset of, I'm guessing that's a B, because sometimes Sascha's handwriting sometimes is a little bit squiggled. So I guess I'll do you guys a favor and I'll just rewrite that portion of the question. So let's do that. Is there a way I can write it without you blocking, please? I don't want my pen stuff to be blocking the stuff. Okay. Okay, so we got this. So let f be a function that maps from A to B. If, well, actually, we probably should define it as a function. So be a function, even though we know it's already a function. If x1 and x2 are subsets of A and B, subsets of A, and B and y1 and y2 is a subset of B, we have the following. Okay. We have the following. But how are you doing, Adam Fighter? What's the best part of your day so far? Okay, so number 1, I did do these like the first time Sascha assigned like this problem, but I haven't done it in a long time, so I got to actually refresh my memory on how to do it. So hopefully this time I fully understand what I'm doing in the process. I only remember like certain parts and pieces. So x1 is a subset, not an element. I believe so. I believe it's supposed to be a subset. Because I think like basically there's supposed to be an x that's contained within x1. So I believe that's the case, but I haven't done this problem in like weeks, so I have to like think deeply about it. So we have x1 and x2 as subsets of A, so we know that those are subsets of A. So we know that all the elements in X will probably be contained in A. We know that all the elements in X2 will be contained in A. So the thing of it is that since we're trying to prove that x1 is a, okay, if x1 is a subset of, okay, that makes it easier. I thought we were gonna have to do that brute force. Okay, so we know that there's an x that exists within both of these two. So I think we'll just write proof. Because you always got to start a math proof with just writing that part. I think we can move this a little bit here. The only thing I don't like about Excel Draw is that whenever you're writing with the pencil, this thing pops up and I'm like, is there a way I can actually get rid of that? I don't want that in the way. Like, I know it's meant for like, you know, just writing, like doing the settings, but can you just leave that as a drop menu? I don't need it blocking my stuff. Okay, proof. If x1 is a subset of x2, there exists an x that's an element of x1 such that x is an element of x2 just drag this more over here so you guys can actually see my handwriting. If x1 is, there exists an x and x2 that such that x is an element this is going to be a good way to, no, that's, I think, no, that's for all, never mind. And x is also an element in x2. It's an element of such that I feel like the memory of solving this is like coming back to me, but at the same time I'm just like trying to formulate the logic here. Because what we want is basically we're trying to get fx1. We know it's going to be a subset of fx2. look at the definition of a subset. I know a subset is basically because it's not a proper subset, so that way we know that all the elements within x1 is going to be in x2. And I know that if we write this, it's like if x1 is a subset of x2, there exists an element x that's an element of x1, such that x is an element of x1 and x is an element of x2. Do we even need that? Probably we don't need that part. Yeah, we probably don't need that. So there exists an x. Now I'm trying to remember how I write that, because I want to say there exists an x that is in both x1 and x2. There's an oh wait, I could have just done with a simple that, such that x is an element of x2. A first order logic symbolic expression. What is that? Maybe to make it more clear, we'll just write such that x is also in x2. So now we actually have to define the functions, because the functions are basically like basically f is a function that goes from a to b. Let's move this up a bit. From A to B, there exists a y as an element now I have to think. Should we use y1, y2, or just b? There exists a y. Since it is a proposition, you start assuming the instance is true, so you are right. You do not need to prove x1 a subset of 2. Yeah. So now I have to basically write such that it's also an. I'm probably like stating the obvious here, because it's like there exists the x that is an element of x1 such that x is also an x2. But I feel as if like that's something that I have to clarify to actually make the logic clear, because it's like we have an element that's in both sets. And I think that will help us. With f mapping from A to B, there exists a y is that do I choose B or do I choose Y1? Maybe Y1. Such that Y1 is an element of F, or maybe equal. Hey, Unstunky, how's it going? Also use exist there makes the statement true, but it's quite weak. You probably want for all instead. Good point. Yeah, good point, because then it shows it's just a singular X. Good point, yeah. Thank you, Unstunky, that's probably like better. What's the best part of your day so far, Unstunky? It's been a long time since I've seen you on my streams. But then again, we were mostly doing lectures the whole time, so I don't blame you for like doing chat because you were trying to make sure that I learned. The one thing I'm afraid of is that I'm not even going to get through this whole exercise because there's 5 parts to this proof. Like right now I'm trying to actually solidify how I would think about this, because I think I did this the first time Sascha assigned this, but at the same time it's like I don't remember, so I think this is a good time to actually refresh it. So now I'm trying to think of the building blocks of what I need to actually think about. Today's shower. Yeah, I've tuned in a little. Yeah, but yeah. No problem, and Stunky. I mean, you're farther ahead in your education than me. I think I'm actually going through what undergrads go through when they're trying to learn proofs for the first time. So with F mapping from A to B, there exists a Y. There's a Y in Y1 such that Y1 is equal to F of X. Okay. And F of X so now that it's like basically equal, that means F of X is in B. No. Now I gotta actually construct. I actually have to make it boom, 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 boom. Like I have to actually like make sure the puzzle pieces are like coming together here. Because what we want is basically F of X1 to be a subset of F of X2. So we know that X is in the subset of X1 and X2. That we got established. There exists a Y that's in Y1 such that Y1 is equal to F of X. Now I gotta make sure that that's solid, that logic. Oh, hello, Omkar. How's it going? What's the best part of your day so far? I don't think I will get to this whole exercise by today. Welcome to math. Yeah, that's true. That's true, yeah. I think proof exercises are always going to be the hardest. Because, like, Sascha assigned me a lot of exercises. Because, like, well, I guess for math majors it's considered a lot because it's in multiple parts. Because I think after this one there's supposed to be 4 more, I think. No, not this one. He gives an example here. Where's the second one? Here's the second one, and I think where's the third one? Oh, here's the third one. So 4 and 5. Yeah, there's about 5 exercises in this one. And I think the second one is like 4? No, there's 5. Yeah, there's 5 of them. So yeah. Okay. Doing well, exhausted though. Best part of my day was went and watched Mission Impossible with friends. Nice, nice. That's good. That's good. Currently tutored a guy in calculus. I lesson prepping for tomorrow. Oh, nice. Calc to do be pain and it's okay. It's okay. I get that. I get that. I have to actually like catch up on studying Calc 3 because like I know some stuff from Calc 3. It's just that I don't know enough to basically go into like higher levels of math. I mean, I also know a little bit of differential equations. I haven't really finished that either. And I think for my personal style, I would probably have wanted to go from like Calc 1, Calc 2, and then differential equations, because then you solidify everything you learn from Calc 2 in that class, and then Calc 3, and then partial differential equations. But some people would probably prefer to do the traditional route, which is basically like Calc 1, Calc 2, Calc 3, and then differential and partial differential. I'm doing differential equations only. It's very tedious and it's like learning a new language. There's so much to learn. Right. But you know, you learn a lot from that. Okay, let's get back into this. Okay, so if x, so y1 is equal to x, f of x, and now with that in mind, in my head, I want to say that basically, thus, f of x is a subset of f of x1. But the thing of it is that, but the real question is that now I'm thinking like, oh wait, do we know that f of x is like basically kind of like within y1 in this case? So that's another question I have to ask myself here. Because I remember Sascha gave me like a little bit of an outline sheet, not giving me the answer, but showing me how the proof is supposed to look like. So let me see if I can find it. Okay, here it is. So you actually have to use A and B in this case. This is supposed to go with the third part, because Sascha told me that he made a mistake on part 3. So I'm just keeping this open so we can see it. I mean, that is pretty discouraging though. Because according to Sascha, it's like, let X be an element of A, logical argument B, such that is a charge an arbitrarily to. Okay. So basically, according to him, it's like, let X be an element of A. And then now we have to make the logical argument. Yeah, let X be an element of A, logical argument, and B. So we have to show that X is in both A and B. So let X be an element of A. Such that X is also in X2. Y, which is an element of Y1, such that Y is equal to f of X. Such that Y is equal to f of X. So we have to prove basically that X is also in B, meaning, this part right here is going to lead us to f of x1 technically would be a subset of y1. And y1 is an element of b. Is x1 such that also is an x2. Y1 is an element of b. Such that x is also in x2. There exists y therefore, since x2 is a subset of x1 is a subset of x2, yeah, I want to say that basically, like, because I know that basically x isn't contained within f of x, and I know f of x is basically like contained within y, which is a subgroup of not a subgroup, a subset of b. Actually, the problem is that I don't know if that's logically coherent. Because x is contained within the function right here, and it's supposed to imply that, you know, y maybe we rewrite this. So maybe as an element of f of x such that y1 is equal to, so let's erase this a little bit so we can have some more space. exists a y that is an element of f of x such that y1 is equal to f of x. And y1 is a subset of b, thus f of x is an element of b. Okay, I feel like we're starting to solidify it a little bit. Hey, Penn Center. I almost didn't see your message there because your name is in purple, is the same as my Siri bot. So if you guys are not familiar with Penn Center, he is an awesome math streamer as well. Check out his stuff. He's doing a lot of awesome stuff on linear algebra and real analysis. Stuff that I'm trying to get into thanks to Sascha. Coming to hang out while working? No problem, no problem, no problem. I'm struggling on the first proof exercise, so nothing much there. So I feel like my logic is sound though, because it's like let x, because according to Sascha, the way I'm supposed to layer the argument is like this. I mean, that's not how I was starting it, but we'll use it as a guideline. So, y is a subset of, y1 is a subset of b, thus f of x is an element of b. If that makes any sense. Yeah, because like basically y is an element of f of x such that y1 is equal to f of x. Okay, so we proved that the function belongs in B. Now we just have to show that x is an element of B. I mean, x has to be put into the function for it to actually turn out to be y1. So I guess, therefore, x is an element of B. I think you're misreading that slightly. Yeah, I probably am. The thing of it is that I feel like I know what's going on in my head. The problem is that I don't know how to write it as a proof. Because I know in my head, it's like, we know that x is an element of x1 and x2, and we know that basically f of x is supposed to equal y, and we know that y is an element of y1. The problem is that we know that x is contained in fx. The problem is that how do we convey that to mean that is x is an element of b? That's the one thing that's kind of screwing me up. And I'm like, I remember I did this like the first time. I mean, with Sascha's help actually. But at the same time, I'm like, why is it that I can't construct this thing? Like I can't even solve it within 45 minutes. I mean, like, what am I missing in the logical argument here? Because we know that all of x is within x1. Like, that's how I'm formulating in my head. Oh, you guys can't see what I wrote on the side here. Yeah, that's what I wrote here. Because I know basically we have to go from like this to this and then hopefully get to this. So we're missing this portion right here. we're missing this portion of the argument. And I'm trying to formulate in my head, but I just I keep getting stuck here. But then again, it wouldn't be math otherwise if you didn't get stuck once in a while. As literally written, that arrow isn't true. Which arrow are you talking about? The one that's pointing down at x is an element of b? B is a codomain of the function, and C is an element of the domain. A is an element of the domain. Yeah, because we know X is contained in A. Maybe it's the way I wrote it. Maybe the way I wrote in this portion of the paragraph here. Maybe I started off on the wrong thing. So we don't expect A and B. The domain and the codomain are unrelated. Maybe it's the way I wrote it, probably. I mean, would you guys consider me struggling on one problem for like 45 minutes progress, or do you think it's like, nah, I should have solved this like a while ago? I mean, that's how I usually feel, but usually like, when it's like computational math, like, you know, you feel like you can solve it faster because it's like, oh, you just have to do the calculation. But here you have to construct like the actual logical argument here. Yeah, I think you have something true in your head, but I'm not sure what it is. So we don't expect A, N, and B. Oh yeah, we already read that. Yeah, I haven't even gone through the first part of the problem yet. Because according to what we're supposed to do, we have to show that the X in A is also in B, but B is usually like B is supposed to be like y1 and y2, and I'm guessing we're supposed to use the functions to be representing the y's here. Sure. I think Sascha made this because I was like I was struggling a lot and I couldn't figure out how to actually formulate it. Templates A and B in this problem are not x1 and x2, but are f1, f of x1 and f of x2. Because you already know that x1 is a subset and x2, by assumption you don't know yet that if f of x1 and is a subset of f of x2, and you use the template to prove that A subset B. So we know that basically these are the subsets. We just have to use this. Okay. So we start off with X as an element of A, and we have to and we already know that, so maybe we can write I know when you write math proofs, or at least what I've read, is that you can't start with like symbols like all of x. All of x is an element of x1. And since f of since x1 is a subset of x2, x is also an element of x2. Well, I bet undergrads go through this all the time. They probably go through like the first couple of weeks, like trying to learn proofs, and they're like, oh my god, how am I gonna pass this course? They're like staring at the question as like, I can't even make heads or tails of it. It's like, welcome to mathematics. Welcome to true mathematical education, proofwriting. So what Nstunky said is basically the template that I'm using is supposed to prove that A is a subset B. I mean, I'll just like write the goal. So prove A subset B. Maybe I should, like, maybe as a habit, I should probably write goal first. But then again, like, proofs are somewhat abstract. I end up wondering, like, what is exactly is the goal I'm doing here? I bet the harder proofs get, the more you begin to wonder what the main goal is. I'll be right back, guys. Just give me 1 second. Alright guys, I'm back. Let's see. I guess we'll continue to fixate on... I think I won't need the study timer for this time, because usually when it comes to like questions like this, I end up struggling for like the whole 45 minutes, and I'm like, oh, I'm not doing anything, so I might as well just continue to be in focus mode. So, alright, all of x is in x1, and since x1 is okay. So that's our first sentence. Now, we have to find a way to, in the next portion, let's erase this part here. I guess I'll put this side as my scratch work. Sort of like, kind of like diagramming what I'm doing. Maybe that might help. So now we have to show that the element x can lead us to f of x, which can to y, thus leading us to b. Now the question is how to write that. I mean, because the way we wrote it before was like there exists a y, which is an element exists the y, which is an element of... Could we put b in this case? So an element of b such that y is equal to f of x. B is supposed to be y1, y2, and yeah, basically y1 and y2 are subsets of b. So basically f of x, so f is supposed to be a function that maps from a to b. Then you don't really, don't care very much about b. Okay. So would it be sound to just write like there exists a y that which is an element of y1, such that y is equal to f of x? Would that be logically sound? Or am I just like mixing stuff up? Y1 is supposed to be part of B. It's supposed to be like a subset of B. I think that you're in a better direction, but checking. Oh, okay. Yeah, because the thing of it is that according to Sascha's template, we're supposed to make a logical argument here where it's supposed to relate that x is an element of B. And I'm guessing x is an element of b because the function is supposed to map like the y's which is within b. So okay, but y1 is not involved in this problem. Yeah, that's the thing. But your A and B are not the same as the templates A and B. So this probably is not what we need then. I know that f of x is supposed to be the thing that unites y and x together in some way, because y is what leads us to b in this case. Because I think the proof is basically saying like, oh, once you have that x is needed for b, or at least the y's within b to exist, then you can basically allow yourself to basically conclude that f of x1 is a subset of f of x2. But how do we write that logically? That's the problem. I did it the last time, but then again, I probably used Sascha's template to help me though. I mean, I feel like I'm somewhat cheating when I'm doing that. But then again, like, could I ever think of it on my own? Probably not. But then again, I haven't exercised proofwriting muscles, so not yet. I probably should say not yet. There's no shame in using a template. Yeah, because like I'm trying to do the approach where it's like, if I don't know where the answer is, I will probably look at a portion of a solution and then I'll be like, okay, I'll write this portion. And then if I haven't figured it out by that time, I would probably look at another portion of the solution. And then I would just keep looking and looking until basically my brain, like, obviously like with each time I look at the portion, I would like think about it. And I'll be like, okay, how do I connect this with this? But to use it, you need to know how the template, how to translate the template into your problem. Yeah, that's also true. Yeah, I think with proofwriting, right, I would get very flustered because it's like, I feel like whenever I look at someone do a proof before, I feel like I'm somewhat cheating myself in some ways, because it's like when it comes to like proofs like with like say even and odd numbers, I love those proofs because they're pretty easy to figure out, at least like the ones that I've worked on. But when it comes to like actually like applying the definitions and actually like trying to write it in a coherent way, I guess like for me, I'm just trying to write it like how mostly mathematicians would write it. But I think it's because like I'm trying to know my audience that I'm hesitating a bit, because it's like I'm thinking of it as I'm trying to write this for a professor, and I know it's not gonna do well if I don't write it right. Because the last thing I want to do is put my hands up and like write anything, and that's like the thing that I don't want to do. And I know you guys are doing your best not to tell me the answer, and I'm kind of happy for that. At the same time, I'm like, I feel like you guys know it, and I'm like, I have to get to the point where you guys are at. But I'm not gonna basically blame out and ask like, oh, what's the answer? And I'm like, no, that would be cheating. So here's a question. What is the purpose of A and B in the template? Like, you could call them U and K, but what's the point of the objects? Well, A and B, A is the domain and B is the codomain, just like you said, and Stunky. Basically, all the elements within A are supposed to map onto B. That is something that's obvious from the template. No, that's in your problem in the template. So in the template, I'm guessing that basically X is supposed to represent the domain, or at least like the input we use, and that's an element of A. And then we have to construct the argument to basically say that this element is the same element that is within our codomain. As X is an element of A was chosen arbitrarily, we have that all of X is an element of A. X is in B, thus A and B is a subset. So I'm guessing from this organized template, we're supposed to do the same thing with this. So maybe I'm not applying the knowledge right. So maybe I gotta do this instead. Let's move this to the side so you guys can see it. Okay, so let's do this again. So let X, let X be an element of X1. X1 is a subset of X2. Because if it is a subset, then basically x, if x1 is a subset of x2, then basically, and it's not a proper subset, so basically all of the elements in x1 should be in x2. Okay. So I think we have to make the existing argument. So we have to show that the element should I be using X or should I be using Y? Now I'm kind of remembering some of the stuff that Sasha taught me, like when I was struggling with this problem. Maybe like this. There exists in X element is better. There exists an X which is an element of f of X such that y is equal to f of X okay. There exists an X such that is that the right way to write this though? Because then the Y just appears out of nowhere. already know that x1 and x2 are subsets. So do we have to actually show that x that exists in x1 is in x2? And then x... Because we have to prove the function of x1 and is a subset of the function of x2. So we have to use x to basically prove that that is true in some way. As x is arbitrarily chosen, we have all of x and x. I mean, I don't think the proof is like basically just trying to prove that x1 is a subset of x2, or at least an element of x is basically within x1 and x2. Is it? No, we have to prove the functions. Because I mean, everything seems well set up. Let's see. I feel like we're on the right track. It's just this part I'm still iffy about, because I'm like, we kind of make y come out of nowhere, and I don't think that's the right approach, because there exists a x that is an element of f of x, but then again, maybe we should just put y. Maybe y is better. Like there exists a y of f of x1 such that y is equal to f of x. Maybe that's the thing we need to do. Exists the y where f of x1 such that... Yeah, I know. My internet's not the best. Unfortunately, it decides to like fluctuate every now and then. Sorry about that, guys, if you don't like the choppiness. I mean, I feel like we're on the right track now, because if we say that there exists a y as an element of f of x, there exists such that y is equal to f of x. So we can conclude from that, therefore, f of x is a subset of f of x1. I mean, that seems to make sense. Because, I mean, we're using y in this case, and y is an element of f of x1, and y is equal to f of x, such that a y would be equal to f of x. Therefore, f of x is a subset of f of x1. I mean, that seems to make sense to me. Now, the question is that can we move forward with this? Because if we look at the template again. Oh, whoops, I realized that you guys can't see that. So, there we go. Logical argument. So our starting point should be our ending point in some way. I mean, I feel like this section, these two sections feel like there might be something that's kind of, I don't know if it flows right. But then again, I probably should just stick to writing something at least. So if f of x is a subset of f of x1, that we kind of establish here. Now, the thing of it is that establishing the relationship between x1 and x2. I mean, in my brain, I'm thinking that, because all of x is an element of x1, and thus, if x1 is a subset of x2, then basically f of x1 should be a subset of f of x2. I mean, that's how I think of it in my head, but at the same time, I'm like, I feel like there's something in between when we make the transition between f of x1, x1 is a subset of x2 to the function of f of x1 is a subset of f of x2. I feel like in the middle there's something missing. Because we know that f of x is a subset of f of x1. Because I feel like if we figure out how to do this one, the second part of the problem is going to be the same process in somewhat of a different flair, but it's probably going to be set up the same way. I'm kind of like debating whether I should upload this on YouTube, because this is just me struggling on one single problem. But then again, I've uploaded a lot of my VODs already, so. But luckily, I'm recording this one, so like I know the VODs are usually has a lot of internet cutouts, so luckily I'm recording this, so when I upload it to YouTube, it's not like that the footage. I think that I'm really glad that the uploads like are not as long, because I think the reason why I was worried about uploading videos like manually is because since my internet's not the best, I would worry about the upload speed. Because I thought it would take like a whole day to upload like the VODs onto YouTube if I actually uploaded it myself instead of using Twitch. But it turned out that it doesn't take that long, which I'm glad. The thing of it is that I don't even know if I'm going to, I don't know what thumbnail I should actually post for this one. Because this one's not a lecture, it's just basically me doing problems. Well, actually doing one problem, or part of a problem. I mean, what do you guys think? Like, I mean, what I wrote here, it feels like it's right, but at the same time, it's like, I know I'm not finished with it yet, though. It's just that I don't know if I'm missing anything in the logic within this portion right here. Because I think that's the thing that's keeping me from moving on to the next thing. Because I feel like, I mean, we can't jump to the conclusion where it's like f of x2 is a subset of f of x1 is a subset of f of x2 yet. I feel like there's something in here that we have to put to make sure that this is official. I just don't know what it is, because we know that f of x1, x1 and x2, x1 is a subset of x2, but to translate that to this, that's the thing that I'm struggling to find. Because I know we have to use x to basically show that part. Maybe I had to start with y. I feel like I might have to start with y in this case. But I think starting with x, it makes it a little bit cumbersome. Maybe that's what I have to do. Let y be an element of f of x1. Pen box. Hopefully if they actually work on this thing and they update it, hopefully they'll be able to make that as just a little box up here. So if I want to adjust my pen, I can actually click it. Okay, so let y be an element of f of x1. So all of y is a subset of f of x1 such that y is equal to f of x. Okay. Now, okay. Okay. Now, gotta think now. Because now I'm trying to remember what we wrote for the last one, and I'm like, I feel like that might actually help us in this case. Yeah, the pen box. Right. Do you think I'm on the right track, and Stunky? Because you went, yes. I don't know if you were commenting on what I said about the, you are, yes. Oh, okay. I bet some of you in the chat were like, "Oh my gosh, it's so obvious he hasn't found it yet." Because I think we were struggling so much to find like the relationship between x and y, but then I was like, wait, f of x is supposed to be with y, so we might as well just use y, because I think that's the hard transition. Because I think with this, it's just like we were trying to figure out how to write the proof with a transition. But I think that was the thing we were not supposed to do. I think. I don't know. So all of y is a subset of... Maybe we should write as an element. We should probably write as an element. That might be much better. I think that's... Yeah, all of y is an element of f of x1. Okay. So now we actually have to find the actual relationship that basically unites these two together. So now we have to think about x2 compared to x1. Or f of x1, I should say. So, such that f of x is a subset of f of x1. Okay. Maybe I should have wrote thus. That might have been a little bit more easy on the eyes to read. Thus is a subset of f of x1. Question, what is little x here? That's also a really good question to ask. Because, like, we don't have... So, basically, we should establish what x is. That's probably a good idea. Oops, left my eraser. All of x is an element of x1. And x1 is a subset of x2. Bingo. Hopefully that establishes it. Now what? Okay, so since all of y is an element of x of x1, is equal to f of x is a subset of f of x1. That sounds like it makes sense. I think. I think. We already and therefore y is an element of f of x1. Okay. Now we actually have to figure out how do we bring f of x2 in the mix. Because we haven't established that f of x2 is like the subset. Now the thing of it is that how do we do that in a proof? Because I mean, we can't say that. Because I think we have to make f of x, like regular f of x, be a subset of f of x2. And because f of x is a subset of f of x1, then f of x1 must be a subset of f of x2. The thing of it is that I'm trying to figure out how to write that in words. I mean, I don't know if I'm on the right track, but hopefully I am. Because on the template, I mean, we established that in the beginning, but maybe... Maybe it's supposed to be f of x, not f of x1. Because then all of y that exists in f of x isn't, says chosen arbitrarily, we have all of it. So maybe this part, so I think now we have to actually unite f of x2 with this portion. The thing of it is how. I mean, can we write that f of x is a subset of f of x2? Because we haven't actually bring f of x2 in the mix yet. I gotta think, like, alright, so how do we bring f of x to lead us to we found a way to get it to f of x1. Now, we have to use this to lead us to f of x2 somehow. And thus, with that will lead us back to f of x1, which would allow us to prove that they're a subset of each other. Just write subset symbol there. You know what? I'm looking at all the Y's and all the X's symbols that we wrote. Maybe we can use those. Let's erase the since, and we can put we have all of Y is an element of f of x1, and y is equal to f of x, and f of x is a subset of f of x1. So is it logically sound to write since all of x is an element of x1 and x1 is a subset of x2 and all of y is an element of x1 such that y is equal to f of x, would that allow us to conclude that basically f of x2 is a subset of f of x? I mean, it sounds coherent, but I feel like we might be missing details. Because all the x's are within the x subsets. And we have that all the y's are within x1, f of x1 in this case. And then we established that basically f of x is a subset of f of x1. I don't think it would make sense if we say like there exists a y that that is an element of x1 that such that y is equal to f of x2. Could we write that? Might as well try. I don't know if it will make logical sense. Such that y is an element of f of x2. Maybe not element, maybe equal to? Maybe because it's supposed to be there exists. So maybe equal to? And thus y is an element of f of x2 we chose x as an element of f of x1 arbitrarily, thus all of y is an element of f of x1 and y is an element of f of x2. Therefore, f of x1 is a subset of f of x2. Is that how we do it? I mean, what do you guys think? I don't know if I just basically pulled stuff out of thin air, but I feel like it might be solid. But, you know, maybe not. Where are we using, we definitely have to use that somewhere. Yeah, you're right. It feels like it's kind of meshed in there. Maybe I have to move that to the top to basically define all the x's. But then again, do we read? Because we only did that to define x within this. Hey, Zach, how's it going? Well, actually, Unstucky, I have to give you a shout out too, actually. Give you a shout out, Unstunky. If you guys are not familiar with Unstunky's work, he also streams some math, as well as some interesting streams involving, like, I think, like a little bit of programming and stuff. And I will also give you a shout out as to Zach. Dang, I'm losing my words today. Might be on later. Oh, okay, cool. I will give Zach a shout out. If you're not familiar with Zach, he is working on, I think he's like about finished with his PhD, so he will be a pro mathematician for us. And he also helps people with their math questions as well, so you can follow him as well. Give these guys a follow. They're really awesome mathematicians in my book. Yeah, I use it loosely. I use it very loosely. Don't worry, Zach. But I look at you guys as like places where I want to be at. Like basically, like I've been struggling on this one part of a proof question for like the whole entire stream, and I'm like, dang, I feel like wow, I'm totally like out of my league here. I mean, I was struggling on it for like 2 hours. Just one part. I'm not even at part 2 yet. Like, chat was basically hearing me mumble to myself the whole entire time. But yeah, you are right, Unstunky. Like, basically we have like X here. Kind of feels like it's kind of pulled out of nowhere. The only reason why I wrote The only reason why I wrote this portion is because you asked me what is little x supposed to represent. But you are right, it kind of feels like it's kind of like just in there. It's like not really doing much. Doing some programming and next... Oh, hey Famish. Next I have psychology. Oh, wow. Godspeed. Yeah, psychology is no joke. I barely passed my psychology course. I think it's because I wasn't really into it. I had to take it for, like, I guess a prerequisite for, not really a prerequisite, it's sort of like a general education prerequisite, actually. I didn't really want to take it, but I had to take it. Yeah, so Zach, we were actually trying to prove that, like, we have this, like, condition where it's like f is supposed to be mapping from a to b, be a function, and if x1 and x2 is a subset of a, and y1 and y2 is a subset of b, we have the following. If f of x1 is a subset of f of x2, then if x1 is a subset of x2, f of x1 is a subset of f of x2. So, I was trying to prove that the whole entire time. And, still trying to improve my proofwriting. It's just the essentials, but I do have a research paper I have to write. But it's nice to take a break from math for a while until pre-calculus. Yeah. Skim through my algebra courses, so I'm finished where I left off before doing pre-calc. Oh, okay, that's good. Pre-calc was pretty hard for me because I took it for the summer. It was very tedious. I didn't fully understand, like, trait graphs until, like, way later. And I was like, oh my gosh, like, why is it that I'm not, like, being able to graph it correctly? I mean, like, for those of you who know proofs, like, what do you guys think of the proof that I wrote? Like, what is it that you think I need to actually, like, look at so I basically, like, can, I guess, edit this proof so it will be much more cleaner. Because, and Stunky, you are right, it's like, the X is there and we probably should use it. I just don't know how to use it. Because I feel like we're getting very close to finishing this proof. The thing is that, like, my proof is not clean. Let's say we have let y be an element of f of x1. All of y is an element of x1, f of x1, such that y is equal to f of x. Let's see, all of x is an element of x1, and x1 is a subset of x2. We have all of y is an element of x1, and y is equal to f of x. Thus, f of x is a subset of f of x1. There exists a y in x1 such that y is equal to f of x2. Thus, y is an element of f of x2. We chose y as an element of f of x1 arbitrarily. Thus, all of y is an element of x1, f of x1, and y is an element of f of x2. Therefore, f of x1 is a subset of f of x2. I mean, when I read it out loud, it feels like it's kind of like coherent, but I feel like I might be missing some things, or maybe I just wrote too much. Or maybe I didn't write enough to clarify certain things. Because I feel like the proof is done, but there's something in me that feels like it's not really complete yet. Like I'm missing some things. Am I like wiling out? I probably am wiling out, but you know, you guys be the judge. But I feel like our approach was really good. Like when I was thinking about basically making y, representing y as like an element of f of x1, I thought that was pretty clever. Because then I was like, wait a minute, we've been using x the whole time, but whenever we try to make x, we try to like unite it in some way. But then that would cause us to like think like too much on like uniting x and y, which kind of like made it a little bit cumbersome. So here's a question: what is f of x2? That's not a primitive object. It's a set you can write out. Can you write out a set builder notation definition for it? For f of x2? Because I mean, we're trying to prove that f of x1 is a subset of f of x2. That is a really good question to ask, and Stumpkey. And I thought we were close. And I thought we were close to finishing this. But then again, like, I think we are close, actually. Yeah, it's just that, yeah, I think there are holes, though. I think that's the thing that's been bothering me, because, like, it seems like you can see these details that I'm missing. And I'm like, okay, what am I not thinking about here? And then you are right, I haven't fully defined what f of x2 is, or x in this case. And I don't know how to make that more clear in the proof. Because I mainly wrote the thing that I underlined here, which is like all of x is an element of f of x. All of x is an element of x1, and x1 is a subset of x2. But then again, like, how does that help us in the proof? Because it doesn't really come up anywhere else. It just defines what x is. But I don't know how I would write like f of x2 though, because f of x2 is not even really defined in this problem. It's kind of used as somewhat of a, I guess, like sort of like a staple. Like, because it's basically saying, like, if you apply a function to these subsets, if you apply a function to like this subset and this subset, and since they are subsets of each other, then that means the function on these subsets should be a subset of each other. It's not defined in the problem. It's a specific case of general construction that you assume to know beforehand. So do I even have to answer that question? Because you did ask me what is f of x2 in this case. I guess like what I'm asking chat is like for anyone that has experience with mathematical proofs, like what are the holes in my proof writing in this case? I think that's what I'm asking, is like what are the holes that I'm not seeing? Because it usually it sometimes happens when I write essays. It's like when I write essays and I think I'm being clever, but at the same time like I have a lot of holes in them that I don't really make vibrantly clear. I mean, and Stunky, you pointed out like 2 of them, which is like what is f of x2 and what is x, you know. I think if you answered the question, you'll see a hole. I mean, I kind of did pull this out of thin air somehow. I don't know if that's the thing. Maybe I have to make this more solidified in in the argument here. Because I couldn't think of anything else. I was like, maybe that's the hole you're talking about. Because I feel like it kind of was a little bit underhanded for me to do that. Because I couldn't think of anything else. Like, how can we establish that f of x2 comes into the fold here? Because we can't say that, oh, f of x1 is a subset of f of x2, because that's the whole proof we're trying to do here. I guess we go through stream without solving one problem. We've just been struggling on one part of a problem. Hey Sascha. I'm actually doing the first problem, the first part of exercise 1 of the first assignment you gave. I'm trying to remember like how I solved it the last time. I mean, like, I'm kind of proud of myself at this point because I was like, oh wait, I've been trying to use X instead of Y, and then I decided to use Y, and I was like, oh, Y makes it much easier to handle. The thing is that, I feel like we got like a lot of the stuff that we needed for the proof, but at the same time, I'm seeing a lot of holes. I think there's a lot of holes in it. I kind of underlined the stuff that seems like it could be the holes that in the proof that I have. Because I did use your template. I was actually using your template before to figure out exactly what I needed to do. The one thing is that I feel like maybe this was a little bit heavy-handed. Which part? Like this part, because I kind of just put that in there because I couldn't find a way to write how I would relate f1 f of x1 to f of x2 in some way. Like right now, I'm just asking chat, like, exactly, like, what is it that my argument lacks? Oh, hello, 2Z. Welcome to the MathSpellBook live stream. What's the best part of your day so far? Yeah, this whole stream we've been like I've been struggling on this problem for like 2 hours, and it was only part 1, and I'm like, oh my gosh. Just got back from a math lecture. Oh, nice. What math lecture is it? Probably more advanced than what I'm learning. I think with computational math, it's just like you basically look at it and you basically, you'll get better, don't worry. I feel like I haven't, I feel like I'm, like, I mean, like, the only thing I'm proud of is just, like, figuring out this part. That was the only thing I'm proud of. It's like, oh my gosh, like, it was so much easier to figure out that I had to use Y instead of X. The only thing is that now, I feel like my proof is finished. It's just that there's some things that are wrong with it, and I don't know what it is. I'm guessing that's analysis. Analysis 2, integration, and a bit of multivariable calculus. You can also try other problems if you feel too stuck. Yeah, but I feel like, I don't know why, it's just that when I feel like I'm struggling with one problem, I feel like I have to constantly try to solve it. Because I feel like this problem is an elevated problem, so I can solve the next one. That's the reason why I was stuck on it for 2 hours. I mean, like, what do you see wrong with my proof, Sascha? Because, I mean, you're the one that created the problem, so... So what I'm proving to Z is, basically, I have to prove that if x1 is a subset of x2, then the function of f of x1 is a subset of f of x2. They are all independent. Yeah, but I remember that the second one, you have to solve it in the exact, like, not the exact same way, but you have to write the proof in the same type of format. So I felt like I had to actually figure out how to write this in order to write this, the proof for this, because it seems like the layout is the same. That's the reason why I was like kind of stuck on this problem, because I felt like if I didn't figure out how to do it, then I wouldn't be able to figure out how to do number 2, even though they're not related to each other. I felt like the proof technique is, or the proof layout would be the same. And Chad has been so helpful, actually. And Stunky has been very helpful in, like, trying to guide me a little bit. Because the thing of it is that, like, when I look at my proof, like, when I look at it, I feel like there's nothing wrong with it, but there's something in the back of my head that's basically telling me there's something there you forgot, or there's something that is not established, or something, a detail that you haven't written. And I can only point out a couple things that is wrong with it. But in my head, I can't think of another way of actually stating those things. Like, probably stating this, the ideas I mean, and they're the ones I underlined. It's like these two things. Or maybe there might be more things there, but... like, for me, I just feel like, I haven't fully established what those things are. Yeah, because there's like a lot of problems. Let's see, what is the second sheet on? Because I know the first sheet is supposed to be on set theory. Oh, and there's a little bit of relationships here too, actually. Yeah, and there's also injective and surjective proofs here. Exercise 2 is the same, it's like functions. I mean, at least I got this far. I can't really like doubt myself for that. We got ourselves this far. We wrote like at least like a portion of a proof. I say a portion because there's stuff missing and it's not fully like complete because there's like holes in it. But actually, actually, Tuzi, that's pretty interesting that you're doing, like, you're analyzing integrals. So I'm guessing you're in real analysis too, or some, in that regard. So line 2 to 4 could be replaced. Okay, so... So you're talking about, I'm guessing you're talking about from here to here, right? Could be replaced by y in f of x1. We know there exists an x in x1 such that so you're saying, all right, so let's just try that. Okay, so what you said is basically as y in f of x1, we know there exists an x in x1 such that y is equal to f of x. Oops. As x1 is a subset of x2, we have by definition that f of x is in f of x2, thus y is in f of x2. Okay, so we don't really need this other line then. Or this. Then... Dang, I wanna... Actually, let's just erase this part. We don't really need this. That was just a diagram for my mental map. Let's just... Oh, I hate it when that happens. I meant to highlight everything. Therefore, choose okay. Arbitrarily, thus this. Okay, So as we have by definition that is an element. Oh, okay. Okay. I think that's what we were missing. Because there exists x in x1 such that y is x. Okay. As x1 is a subset of x2, we have the definition that. Yeah, I think this is the part I was missing because it was hard for me to unite both x1 is a subset of x2 with like the functions. That's probably what I was missing. We have by definition that f of x is an element of f of x2. Thus, y is an element of f of x2. We choose y to equal to be an f of x1 arbitrarily. Thus, okay. I mean that sounds better because now we know the relationship between like x1 subset of x2, and then we put that in the definition on how we actually unite the two. Okay. Yeah, that makes it a lot much easier to see. Because I think it was hard for me to actually unite these two things. Because I was like, I know I have to use the proof, I have to use the first part to basically prove the second part. And the second part, I think it was a little bit, I didn't have the pieces to like bring that together. But that really helps, Sascha. Thank you. I mean, I am disappointed that I didn't think of that. But at the same time, like, you know, like I'm still new at this, so I probably shouldn't be too disappointed about it. Proofs are hard, so it's all in the matter of learning. It's like basically when you play a game and you tried your best, but you know that you're still lack skill, so you have to actually try to find a way to get better by like playing more games. So I think that's how it is with like math or physics, both math and physics. Proofs are hard is real. yeah, it's true. Okay, guys. Well, at least Sascha helped us with the last part of our proof. Hopefully that looks good. No, I'm not in uni. I'm actually doing this as a hobby. I'm actually learning math as a hobby, as well as physics. I actually been struggling with this one physics problem. I refuse to look at the answer, and I've been like struggling on it for like the past 2 days. But I don't think of it too often. Like I think of it like whenever I get to it. I usually do physics problems in the morning, so I feel as if I'm actually trying to apply the math that I learned. It's not like high advanced physics, it's just like university physics. Like, you know, the typical physics that you would learn in undergrad. Right now I'm doing like a static equilibrium problem. So I could probably show you 2Z. So the problem is that we have two walls, and there's this little mechanism in here. It's like a bar or something, and then we have like springs attached. So there's like 2 springs on one side, and there's 1 spring on another side. And the question is that we have the distance for this spring, for these 2 springs, and these springs like F1, F2. We already know the numbers with these forces, and we know the distance with it, so we'll call it X1. The problem is that I have to figure out what this distance is, just X, and we don't know what F3 is. And I've been trying to figure out exactly like how to think about this problem, like the setup of it. I know it has to revolve around work, so I know work will help me in this case because there's distances and forces. The problem is that I haven't been able to think about the setup of this problem, like how to set it up. So because I know both of these sides, they have to equal like 0 because there's no external forces on it. The thing of it is that I don't know how to I'm trying my best to like think about how I set it up, and I think setting it up is like the hard part. But that's like the problem in the nutshell. It's probably a very simple problem for all you guys that are into physics. I'm year 1 in physics course. Oh, okay. I see. That's cool. Okay, guys, I think I'm going to end stream for now. For all those that love math, love physics, you know, consider dropping a follow for the channel. I would really appreciate it, because studying with you guys, whether you be in uni or whether you're doing it as a hobby or whether you're doing work for school or something like high school or something, like, you know, you're always welcome here. I don't know that much about, like, you know, like proofs or like higher level like STEM fields, but at the same time I'm willing to learn from like those that are actually studying that right now, because you guys are just as much as teachers to me as, like, you know, I try to actually put math content out there for you, as well as physics content as well. So I will drop I will basically put the Discord server in the chat for Twitch. If you're watching this on YouTube, all the links will be in the description down below. And thank you 2Z for the follow, much appreciated. I will probably upload this VOD on YouTube. If you guys just want like productive streams or productive videos to keep you guys busy while you study, you know, you can always like watch my VODs on my channel. And I also have my Uncle Talks channel, which is where I play video games. So you guys can drop in on me there too. We can probably talk about more things there than just math. But yeah, and also I would like to personally thank like everybody that helped me in chat for this problem, because this problem was pretty tough. It was pretty tough. I mean, I was stuck on it for 2 hours, so, you know, what can you do, huh? What can you do? This is part of my proof writing journey, and, you know, the thing with me is that whenever I learn, I think the reason why I was able to learn, like, I think, like, basic proofs with, like, even numbers and odd numbers is because I was shown examples of those. But then, like, when you think about proof, like creating proofs on your own, you don't really have examples to go on, so you actually have to try to construct on your own. And I think constructing it on my own is the hard part that I struggle with, because I always feel like there has to be someone that has done this before that I can emulate. But at the same time, like, you know, sometimes life is not that easy. You actually have to try to create the solution on your own. And that's the thing that I really struggle with, is like basically constructing the formulation of how to approach the problem, and then try to put the solution in a way that makes sense to me in that way. And I'm pretty sure many of you out there probably struggle with the same thing I have. But yeah, so if you guys are watching this on YouTube, you know, like, drop a comment, hit the notification bell, you know, sub to the channel if you're watching this on YouTube. And thanks for joining us for today. Let's see. I don't know if we should do a raid. We haven't done a raid in so long, actually. Let's see if there's anybody streaming any math content today. Let's see here. And I think tomorrow we're gonna basically do we're probably gonna do more math proofs. So I will be struggling more. Okay, it looks like the Academy of Useless Ideas is streaming, so we can raid into their channel. So I will do the raid command for us. The raid message for us. And then you can copy and paste that at your leisure. And then we will commence the raid. The Academy of Useless Ideas. I mean, they say that it's useless ideas, but it's mainly just pure mathematics at its true beauty. Oh, thank you for the Prime sub, 2Z. Much appreciated that you're the first Prime sub. Thank you for the Prime sub. Much appreciated. Okay, guys, we will commence the raid. And I will say this to you guys now. Always remember, everyone is precious. You guys is just as precious as everyone else. And I will see you guys on Academy stream. So take care, guys. Bye-bye.